Hi, this lesson is about how to solve a system of linear equations when you have three equations and three variables. So in this first example, we have a system of linear equations that I labeled equation 1, 2, and 3. Um, and I'm going to be using a combination of elimination and substitution in order to be able to solve for the three variables. And when you get one answer for X, one answer for Y, one answer for Z, then again, you will have a independent system. And instead of the intersection being a point like they were with two equations and two variables, it's the intersection of three planes. So in this example, I'm going to eliminate the x's, and you can make any choice you want. I decided that I wanted to eliminate the x's, and I'm going to work with equation 1 and 2, and I'm going to subtract equation 1 and 2 in order to eliminate the x's. So I wrote equation 1 and 2 below, and when I subtract the second equation, that minus sign gets distributed across this. So my x's will cancel, my y's become minus negative 2y when you subtract. The z's become minus 2z, and 9 minus 23 is negative 14. I labeled this equation 4 so that we could easily discuss it later. So once you make the decision to eliminate a variable, like I did here, I eliminated the x's, then I have to eliminate the x's using two other equations. So I can use either equation 1 and 3 or equation 2 and 3. Doesn't really matter which pair you select, you just have to eliminate the variable x. So what I decided to do was to multiply equation 1 by the number 2. So I'm going to double this whole thing. And then I'm going to that, um, subtract equation 3 from it. So when I double equation 1, I get 2x plus 2y plus 2z equals 18. And then here is my equation 3. So when I subtract them, the two x's will cancel. So I've accomplished what I set out to, which is to eliminate the x's in this pair as well. The y's become 2y plus y is y, and the z's 2z plus z becomes plus 3z, because remember you're distributing that negative. And then 18 minus 7 gives me 11. So I've labeled this equation 5. So now equation 4 and 5 are two equations with two variables. So I can now apply techniques that I explained in the previous section. So I want to eliminate one of the variables in order to solve for the one that's left. So I'm going to take equation 5 and multiply it by 2, and then I'll add it to equation 4. So equation 5 doubled is right here. It's 2y plus 6z equals 22. And here is equation 4. Bring it down, just copy it. So when I add those two equations, the y's will cancel. And when I combine the z's, 6z minus 2z is 4z, 22 minus 14 is 8. So now I'm in a position where I can solve for z, and I get z is equal to 2. Once you get one answer, then the rest you can find very quickly. Now I'm going to plug in z equal to 2 into either equation 4 or 5. And what that will allow me to do is then solve for y. So I decided to plug it into equation 5. You could have easily picked equation 4 and gotten the same answer. So equation 5 with z replaced with 2 is y plus 3 times 2 equals 11. That gives me y plus 6 equals 11. Subtract 6 from both sides, you get y is equal to 5. So now I know the answer for y and z. I just need to figure out what x is. And so to figure out what x is, I just replace the y and the z, the 5 and the 2, into one of the original equations. So I decided to plug them in to equation 1. This is what equation 1 looks like. X plus y plus z equals 9. replacing the y with 5 and the z with 2, I get x plus 5 plus 2 equals 9. That gives me x plus 7 equals 9. Subtract 7 from both sides, you get that x is equal to 2. So you present your solution in the order x, y, z. X is 2, y is 5, z is 2. There we have our independent system. Okay, in the next example, um, this is one for you to try. And so I'll just get you started. So in this equation, I have three linear equations because all of the exponents are raised to the first power. They have three variables, so therefore three equations. And again, you have to strategize. What variable do you want to eliminate first? And I decided that I wanted to eliminate one variable x by adding 1 and 3, because this one is a positive x and this one here is a negative x. And once I do that, I will end up with something that works out really easy, because not only do my x's cancel, but my y's cancel as well. So I'm able to get a solution here much quicker than I did in the previous example, because I can solve for z right away. And once I solve for z, you're really ready to go, because then you can plug in z in equation 2 and solve for y, and then plug into either equation 1 or 3 to get your value for x. So you should try finishing that up. That's it for this lesson. Good luck.